function, yeah, to plug into, but you don't need to plug into anything because they've given you inputs and outputs. So they've given you X's and Y's. So we can just use that stuff. So I love the fact that they give you tables. Be careful when they give you tables though, because they may not have a uniform width that you can pull out front. So you might have to figure out width times height of this one plus width times height of this one plus width. So if you don't have the same width, so be careful of that. This one we do have the same width. So just let me show you how you would do this, and of course your calculator is your friend, of course. Use Simpson's rule to estimate the total amount of data transmitted from midnight to noon as reflected in the following graph and table. Well, we kind of see the graph, I don't know. I think it's the table that's gonna give me more information, right? So when I'm looking at this, midnight to noon is 12 hours or that many seconds, okay? So, let's see, we got the hours. I'm gonna do this in seconds. So that would be when, I'll put this over here, when T equals, what is that, 43,002. That'll be new. Okay, so I'm looking for the total data. So, you know, here, not reporting a lot of data, but then it starts to report a lot of data. I think that's the area under the curve. All these heights. Add them all up, total data. So I probably want to find this. The area, let's see, up to 43,200. And that's going to be the integral area under the curve at the x-axis from 0 all the way up to 43,200. We call it d of t. So here's my function, d of t. I don't know what d of t is. I don't know what this function is. I don't need it. I got the outputs over here, dt. I assume that's my variable dt, change in t. So let's see. I'm going to say I'm going to need change of t. 43,200 divided by 12. What is that? 3,600. And I'm going to find this by estimating using Simpson's rule. I'm going to estimate that. Is there a better black pen? That looks a lot like it, doesn't it? I meant that to be an S. Make it look more like an N. Okay. With 12 pieces. Why 12? Because that's what they want. Hey, remember Simpson's rule? We need an even number so that it comes out right. In Simpson's rule, parabola, so I'm using the left, the right, and the middle, the top of that parabola. So this is going to be the change in t this time over 3. It's a consistent width each time, so I don't have to do separate widths in here. And then I'm going to have times the height of each one, right? So we've got the t of 0. Remember Simpsons? It's
plus 4.
Yeah, plus, and I start alternating, right? 4, 2, 4, 2, 4, 2, 4, for the next one. 3,600 plus 2 times the next one. Forget that D. It's the function plugging in 7,200 next time. Plus dot, dot, dot. My last one is gonna be this one.
Yeah.
Right. D of 43,200. And then if I back up, I gotta end with the 4. 4 times D of, oh, why am I doing it? 4 times D of, now I'm gonna plug in 39,600. Sorry, it's looking so tight here. One in front would be 2 times D, plug it in the one before that, 3,600, 36,000. Okay. I got 13 pieces there now.
Wait, what'd you do?
I'm gonna have 13 pieces there all told.
Oh, okay.
So that's gonna be, if you wanna go ahead, that's gonna be 1,200 out here, right?
Yeah.
But what I like about tables is I don't have to plug each of these into a function, because I don't know what the function is. I already know the output. The output is right here. So this is like my X, and this is like my Y. And I had to continue over here, this is like my X. So the height each time, I've got, here I got 3.2 plus 4 times 2.7 plus 2 times, oh, I got that right, 1.9. And I'm just gonna keep going 4, 2, 4, 2, 4, 2, plugging these in, right? 4, 2, 4, 2, dot, dot, dot. Of course, I can't just dot, dot, dot my calculator. Plus 2 times, let's see, I've done it all the way up here, so it's 2 times, that output is 7.1, plus 4 times, that output is 7.7, plus 1 times 7.1. Of course, in your calculator, you're actually gonna have to, which you get practice with, have to put in all those pieces. But a table, I love it. I don't have to plug this in to get my output. I can just go from here to here. Big time saving. Show me some more tables, College Board. We love the College Board. Okay, so when I do that, and then don't forget out here, you've pulled the width out because the width has been consistent. If you notice this 3,672, it's exactly the same interval each time. But if it's not the same interval, this is not gonna be consistent, so you're gonna have width times height plus width, 4 times width times height plus 2 times width times height. That'd be a pain. But anyway, you get all that in your calculator. Don't forget to multiply the final, or the almost final answer by 3,600 divided by 3 or 12, which I've done. So if you do all that, I get 143,808. I am not gonna put square units there. Because this represents all the data. But I've done it the same way as I would, even though I did say area. So this is actually an approximation. I say equal here because that's what Simpsons puts are equal. But if you want to say, hey, this is approximately what it's going to be. And it's probably pretty darn close, right? Since
Do you know the actual answer?
no, because I don't know the function.
Okay.
I can't actually take the integral because I
Over
don't know the
Simpson,
function.
why did Simpson know that this was it? What led him to the?
Questions on this? Hopefully you're thinking, oh, give me a graph, give me a table, it's so much easier. Already give me the output, I don't have to plug it into a function. That's so much easier. And don't give me so many Simpsons questions too. That would be better. Now all of a sudden you're looking at those rectangles thinking, oh, that wasn't so bad. The trapezoids in Simpsons, ugh, what a pain those are. But you might be asked them. So you gotta get practice with them. Which is what you have today. Practice all of these. Practice. That is it.